Good morning, Year 6, and welcome to today's home math learning. As I explained in today's home learning document, we've already done the things that are on white rows, so I'm going to attempt to do a similar video about algebra and today's learning focus, which is exploring simple one-step function machines. Okay, well, to start the lesson, we'll do the same flashback as they do on the website. So if you'd like to pause the video now and have a go at these questions, I will go through the answers with you in a moment. Okay, so question 1. If 10% of a number is 40, what is the number? Well, we know that 10% is the same as 1/10. So 1/10 of a number is 40. That means the whole number must be 10 times that. So 40 times 10 is 400. The answer is 400. Number 2, work out 50% of 120. We know that 50% is the same as a half, and a half of 120 is 60. Number 3, multiply 4.36 by 100. Okay, when we multiply numbers by 100, they move 2 places to the left. Each digit moves 2 places to the left. So I might start with my 4. I'm going to move my 4 2 places to the left. That becomes 400. The 3/10 becomes 30, and the 6/100 becomes 6. So the answer is 436. Okay, for question 4, work out 3/4 plus 3/5. At the moment, these fractions are in different size parts, so we need to make them into the same size parts and find a common denominator. The common denominator is always going to be the largest denominator or a multiple of the largest denominator. We can see that the largest denominator is 5, but 4 doesn't go into 5. So we have to find a multiple of 5 that 4 will go into. If we use our multiplication facts, we will see that 5 times 4 is 20, and 4 will go into 20. So we can make both of the fractions into an equivalent fraction with a denominator of 20. So that's the actual answer, but what we do is with our 3/4, we make that into 20ths by timesing it by 5. And 4 times 5 is 20, and 3 times 5 is 15. Then we will change our 3/5 into a fraction with a denominator of 20. So we know that 5 times 4 makes 20. So we need to do the same to the numerator. 3 times 4, which is 12. Now we've got 15/20ths plus 12/20ths, which together make 27/20ths, which we can convert into a mixed number fraction of 1 whole and 7/20ths. Okay, moving on to today's lesson. So please write the learning focus in your maths book, and it is I can explore simple one-step function machines. Okay, but what is a function machine? Here I've got a picture of a function machine, and this is a one-step function machine. A one-step function machine is where you perform just one operation on the input number. So here you can see that the input number is 3. It's gone into the function machine. The function is multiplied by 2, and then the output is 6 because 3 times 2 equals 6. For each number you put into a function machine, there is an output. Now today you'll also be working backwards to find the input number if you were just given the output number. So for example here, if you were given the number 6 and you didn't know what the function was, you'd have to work back and find out that the function was you would do divide by 2 to find out that the function was times by 2 working forwards. Okay, and if you were given a set of inputs and outputs, you should be able to work out the function. Okay, we'll look more about that in more detail later. Okay, so here is a function machine. We have our input number, the function is multiplied by 4, and then we have an output number. So you might want to pause the video and see if you can answer these questions where the different inputs are given and 2 different outputs are given. Okay, so looking at the first question, what is the output if the input is 2? So we would input 2, we would multiply by 4, and we get the answer of 8. What about if what is the output if the input is 7.2? This time we will input 7.2 and we'll multiply it by 4. We know that 7.2 multiplied by 4, we could double it and double it again, we get the answer of 28.8. Okay, what about question 3? What is the input if the output was 20? This time we have to work backwards because we know the output. So we have to use the inverse operation. The inverse operation of multiplication is division. So this time we are going to, instead of multiplying by 4, we're going to work backwards from our 20 and we're going to divide it by 4 to get an input number of 5. Okay, using that information, we can then answer number 4. So what is the input if the output was 22? Well, this question is only 2 more than the previous question. So if we know that 20 divided by 4 is 5, then 22 divided by 4 is just going to be 1/2 bigger than the previous answer. So we should get an answer of 5.5. Okay, well done if you got all of those right. Okay, now our next question, it's exactly the same principle. The question is just being laid out in a slightly different way. So we're given the inputs on the top line and the outputs on the bottom line. So have a little think before you work this one out, which are going to be the questions where you use the inverse operation. Okay, you might want to pause the video now and I'll go through the questions with you in a moment. Okay, so quite simple, just adding 5 each time. So 5 plus 5 is 10, 5.8 plus 5 is 10.8, 10 plus 5 is 15, minus 3 plus 5 is 2, minus 8 plus 5 is minus 3. Working backwards, we would do the inverse, which would be subtract 5, 9 subtract 5 is 4, 169 subtract 5 is 164, and 0 subtract 5 is minus 5. Okay, well done. Okay, here we're going to have to look at a range of inputs and outputs in order to work out categorically what the function can be. Okay, so we can't just look at the top number, we need to have a look at all of them. Okay, if you'd like to pause the video and have a look at this question for me. Okay, so we can see that on the top line we're going from 10 to 5. So we might think to ourselves, well, it could be divide by 2, or it could be subtract 5. We don't know for sure, so we have to then look at the other questions. Well, the second one's going from 24 to 12, so it can't be subtract 5. So we must think to ourselves, it must be divide by 2, but to make sure we look at the bottom one. 7 divided by 2 is 3.5, and it is indeed divide by 2. Well done if you got that one right. Okay, then for the next slide. Eva has a one-step function machine. She puts in the number 6 and the number 18 comes out. What could the function be? How many different answers can you find? So here there's going to be more than one option because we've only got one input and one output. Okay, pause the video to have a go at this one. Okay, so we can see from using our multiplication tables that 6 multiplied by 3 is 18. Or we could, if we were adding something, we could see that it could be add 12. So the two options it could be is plus 12 or multiplied by 3. Okay, for the next question. This time we've got a range of inputs and a range of outputs. Okay, so here we have to make sure that the function fits all of the inputs and all of the outputs. Pause the video now if you want to. Okay, so here we can look at the top one. Go from 2 to 8. Well, it could be multiplied by 4. Or it could be, perhaps, add 6. But if we look at the other questions, that's not going to fit for those outputs. So here we must maybe now look at the relationship between the numbers. So if the multiplication and the addition function doesn't work, let's look at those numbers. What do we notice about those numbers? Well, if you look at 2 and 8, they're both number bonds to 10. 3 and 7 are both number bonds to 10. And the same is number 6 and 4 are number bonds to 10. So actually, the function here is you subtract the input number from 10 to get the output number. So for example, 10 subtract 2 is 8. 10 subtract 3 is 7. So to answer the last bit of the question, what is the output from the function when the input is 16? We would have to do 16 subtract 10, which would be minus 6. Well done if you got that right, because that was a tricky one. Okay, and for the last question, Dora puts a number into the function machine. The function is divided by 2, and then she has an output. We don't know what the input number and the output number are, so we need to find them out. But what we do know is that Dora's number is A, a factor of 32, B, it's a multiple of 8, and C, it's a square number. Okay, pause the video and see if you can find out what's the input number and what's her output number. Okay, let's look through the facts that we've got here. So we know that the input number is a factor of 32. So I just listed all the factors of 32 to help me out here. So I know that the factors of 32 are 1 and 32, 2 and 16, 4 and 8. That doesn't help me though, because that's quite a lot of answers. So I need to narrow it down. So the next thing, it's a multiple of 8. Okay, so all the multiples of 8 we have there are 8, 16 and 32. Still, there's 3 options, so that doesn't really help. We need to narrow it down even further. So we know it's a square number. Of the numbers 8, 16 and 32, 16 is the only square number. Okay, so the input number must be 16, therefore the output number is 8. Well done if you got that one right. Okay, now have a go at the white rose questions that I've put into the document, and I'll give you the answers on Class Dojo later. Okay, good luck and speak to you soon.